Let's Talk Chemistry with Pastor Dan. We're looking today at dimensional analysis, unit conversion, factor label. All of those mean the same thing. And this is a very, very, very important concept because, in effect, we hit back at this one way or the other over chemistry over the same time over and over again. So this is something we have to get down. That's why we're going to practice it a couple of days to make sure we're solid and make sure we run through it. So what exactly is unit conversions? That's a means of converting between value units while maintaining the same value. So what we're going to do is take a number like 1 foot is equal to 12 inches. Now, if we look at that, that's an equality, that's cool. I can, in effect, divide both sides by clone it and clone it again, and 12 inches. So 12 inches over 12 inches, that's 1. If we multiply by anything by 1, it's still that same number. Now, if we do the same thing over here then, and when I divide through 1 foot over 12 inches, that's the same number, and that's also still just 1. It haven't changed the value of the number at all. We're just changing units. And so that's the process we go through in order to do that. What exactly is that process? Well, we're going to go through it specifically. We're going to always want to put the given information over 1. So that way it's set up in a way that we can make fractions and cross things out and get it to work. Second, we're going to identify all the qualities that we need to convert from the given units to desired units. All right? We're going to make a fraction, which is called a converter, to get out of one unit that you're in and the units that you desire. And then we'll continue this process until we get to desired units. We're going to multiply. And then lastly, as always, make sure that we do sig figs and we're good to go. All right, so there are certain converters that we're going to have to work with, and we have to always use those. I'm going to be consistent. So if we're doing length, I always want you to use length. I want you to always use, this ball going, there we go. I always want you to use this equality between inches and centimeters. Now, I know some of you know the number of inches in a meter and all that kind of stuff. It's just simpler if we keep it at a base unit. For volume, we're going to use 1 liter is equal to 1.06 quarts. And for mass, got that one spelled right, 1 pound is equal to 454 grams. Now, in the description box, I'm going to put what I call my unit converters. So if you pull those up, you have a list of all the different possible conversions that you're going to need, not that all that exists, but that you might need while we do these problems. So let's look at a problem. Let's say we take 766.400 milligrams, and we want to convert that to ounces. Now, I know we put the given over 1, but I'm going to start with the equalities. We're going to start with 1,000 milligrams is a gram. Now, that gets us out of milligrams into grams because remember, the equality that we went between English and metric is 454 grams is 1 pound, and then pounds, 1 pound is 16 ounces. There's also ounces to quarts, but that's a different unit. All right, so let's start with our given over 1. So that way we're set up. Now we're going to make a conversion, a fraction. We're going to multiply using that first equality. We're going to put milligrams on the bottom. The reason we put milligrams on the bottom is so that they cross out. So again, remember, this is 1. It doesn't change the value of my number, but it converts it from milligrams to grams, crossing out as we go. Now we're going to use the next equality, which is going to be pounds, grams to pounds. Again, grams go on the bottom, so the grams cross out. Pounds go on top, so my grams cross out. And then I'm going to do the last equality, 16 ounces over 1 pound. We see my grams cross out, my pounds cross out. I'm left in ounces. That's what I need. I can take my calculator, take your handy dandy Joe Dandy calculator, do your gazynthesis. This goes into this, 166.400 times 16. On the calculator should read 12262.4. Now, every time you hit divide, I want you to hit equal because your calculator is going to function exactly as you tell you to. So if you do that number, divide by 1,000, then divide by 454, and not hit equal at time, it's actually going to divide 454 into 1,000, not into the whole number. So we're going to take that, divide it by 1,000. Now we get 12.2624, and then we divide by 454. When we do it, we get the answer of, on your calculator, you should have 0.027009692. Now remember, we always have to remember sig figs. So we look over here. I have 766.400. The 7's not a 0, it's significant. 6 is not a 0, it's significant. 6 is not a 0, it's significant. The 4 is not a 0, it's not. So I've got 4 sig figs right there. How about these 2 zeros? These 2 zeros are after a number, after a decimal. They're showing exactness, so they're significant. So I have 6 sig figs. So I come over here, 1, 2, 3, 4, 5, 6. I look to the number to the right of that 6, that's a 9. So 5 or greater, we round up. So we get 0.0270097, and it should be ounces, not grams. Same thing down here. All right, and then that would be my answer. All right, let's skip on down to here, and let's do this one. Now this one's going to be a little more interesting. 71.5 miles per hour is equal to, and we want it in meters per second for conversions. All right, let's get all of our equalities we need. Well, set our given over 1, it did that time. 71.5 miles, but over 1, but hours are going to be on the bottom because I've got a unit here. So it will actually be on the bottom with the hour. Last time we didn't have that because there were no units on the bottom. All right, all our equalities, we're going to say 1 mile is 5,280 feet. 1 foot is 12 inches. 1 inch is 2.54 centimeters. That's my length metric to English conversion. 1 meter is 100 centimeters, and 1 hour is 3,600 seconds. You can do hours and minutes, minutes to seconds, but remember 60 times 60 is 3,600 anyway, so we're good to go. So we start with our given, then use that first equality, 1 mile is 5,280, because we're in miles, we want to use that one. Miles on the bottom, feet on top, and we're going to do feet to inches, so feet on the bottom, inches on top. Then we're going to do inches to centimeters using that third one, and then we're going to do centimeters to meters. Now, our units all cross out here, so we're left with meters, and that's what we want in the numerator. Good so far. But right now, we're meters per hour, and we want meters per second. So we're going to use that last fraction. Now, this fraction, what we've been all along here is whatever we want on the bottom, but this one's already in the denominator. So in order to cross it out, we're going to have to put hours on top and seconds on the bottom. So that way the hours cross out. Now when we multiply through, we're going to get meters per second. All right, so let's take our hand calculators. 71.5 times 5,280 times 12 times 2.54. Now we don't need to multiply by 1. Hit equal. We go straight across, multiply across. You should have on the calculator 115,06809.6. Now, remember time. Every time we hit divide, we're hit equal side. So divide by 100, equal, and then we'll divide by 3,600, equal. Now, on your calculators, you should see this number, 0.31.96336. We go back here. I've got 3 sig figs here. Cool. But what about the rest of these? Remember, this is an equality. These are all equalities. If we go back to the rules of sig figs, we see that the number of sig figs for equality is infinite. So which is smaller, 3 or infinite? Of course, 3. So we have infinite, 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 infinite sig figs, and only 3 in my given. So I have 3 in my answer. So therefore the answer, the 3 sig figs, 31.9. Then we're going to write to 6, round up. Answer is going to be 32.0. And again, this should be ounces and not grams. All right, awesome. So last concept we'll look at today is something called scientific notation. Now, it's a little bit different, but it's a way of, whoa, jumped ahead there. Scientific notation is a way of expressing very small or very large numbers as a coefficient and a power 10. It just makes it easier to work with. So we're not hitting the 0 button all the time in the calculator and run for that. So how do we do this? Well, first of all, we're going to take a base number between 1 and 9.99999. Can't be 10, can't be a decimal. It's got to be at least 1. Then we're going to take a multiply sign and a factor of 10. Now, if the number's a decimal, make the new place, it's going to be negative. If it's not a decimal, it's going to be positive, and then remember our sig figs. So let's take a look at one. Let's take a look at this one. 120200000000. So you just pound away on that 0. All right, so we need our base number. Remember, the number has to be at least 1 and can't be 10. So if you look at that number, that base number would be 1.202, okay? Because I've got these numbers here, and it can't be bigger than 10, and it has to be at least 1. All right, so we're at this place times 10, and we're going to move a decimal from this place to this place. So we're moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the value is not a decimal, so it's going to be positive. So the expression is going to be 1.202 times 10 to the 10th. All right, let's try this one. All right, now I've got a bunch of zeros. 0.000004500. All right, base number. Also remember sig figs. Got 4 sig figs, 4 sig figs. Good to go. All right, let's try this one. Now the base number is 4.500. Why did I include those 2 zeros? Well, you see they're significant over here. Remember, they're after number, after decimal. They're significant, so they have to be here, expressed the same way. We're going to do times 10. Now we're going from this place to this place here to make it 4.5. And we're going 1, 2, 3, 4, 5, 6, 7, 8. But it's a decimal, so the number is going to be -8. That works it from there. That's our answer. All right, so that's how we do scientific notation. All right, so let's practice these. Copy these down. Stop the tape. We'll recording. I'll work it through afterwards, but I want to see if you can try these on your own first and then see what you get. All right? So pause it, work on it. We'll come back and work on it together. So let's look at this one. So let's take the first problem we're going to get. We want to know how many liters are 550.50 gallons. All right. So my equalities, I have that 1 gallon. Gallon is 4 quarts. And I have that 1 liter is 1.06 quarts. Okay, let me move that out of the way so you can see that expression there. There we go. Get over here. Try moving it down here. It doesn't want to move. All right, hold on a second. There, you can see it right there. All right, awesome. Now, again, gallons goes on the bottom. Gallons cross out, we get to quarts. And then we want to get to liters, so 1.06 quarts is 1 liter. Quarts cross out. We're going to take 550.5 times 4. So 550.5 times 4, and we get 2202, and divide that by 1.06, and we get 2077.358491. I have 5 sig figs. After 5 sig figs, it's 2077.4 liters. That's correct. All right, now for this one, our base number has to be 5.2009. Remember, can't be 10, has to at least be 1. And we're moving it from this place to this place. It's going to be positive. 1, 2, 3, 4, 5, 6 times 10 to the 6th. There we go. And for the last one then, it's negative, so it's going to be decimal. Put down your base number, 176. Because it's a decimal, we're going to the left. We're in the left 3 places. 0.00176. All right, we will practice these tomorrow and probably the next day to make sure we're good to go. Hopefully that wasn't too bad. Just hang in there. Know God loves you, and He has a purpose for you. Take care.